Yeah, welcome everybody to our guest lecture today within the course Databases. As announced, we also have a small bonus quiz that is based on this guest lecture, and we just released this bonus quiz on my courses. So if you want, you can also now open your My Courses account, your My Courses access, and try to answer the quiz questions online as you hear about the contents or the concepts in this guest lecture. So I'm very happy to have Mikhail Kuklin, who is a senior data engineer working for Sanoma, which is, as understood, one of the largest, if not the largest, media company in Finland and also active beyond Finland. So they have a lot of data. And Mikael will tell us about data platforms or enterprise data platforms that must cope with a lot of data, rapid or high-speed data streams. And yeah, I hope you will see a bit how the theoretical concepts of our course, in particular the relational model or relational data model, they can actually be used or are used to design practical enterprise data platforms. But without further ado, thanks a lot, Mikhail, and the floor is yours.
Yeah, hi. So first of all, thank you for introduction and thank you for having me here today. Maybe I can start with some very basic introduction information also. In generally, you pretty much that you can read the title on the slide. So today we will talk more about real-world application environments. So mainly we will go beyond theory and look at practical application challenges and in generally how modern data platforms are built and used in actual organizations. Traditionally, again, I can start with introducing myself with more details. As you can see, my background is rooted in academia. So I spent about 10 years working in the field of so-called computational material science, primarily focusing on simulations and using high-performance computing. I spent actually about 4 years in Aalto University. I became increasingly interested in applying AI and machine learning to material science problem. And this curiosity eventually led me to transition out of academia and first into the world of consulting, where I worked on the various data-related projects. So it's meaning data engineering, machine learning, data analysis, and architecture. And over time, I discovered that my passion lies basically in the field of data engineering and architecture, so more technology-oriented roles. And since then, I've been working as a data engineer, helping organizations build and manage data platforms. So as you can see, maybe also that my path shows that you don't necessarily have to have all figured out what you kind of want or what you will do in the future. Because the practical experience can change the opinion. And for me, it was, as you can see, through exploration experience, basically. And maybe one final note. So when we had initial meeting with Alex to plan this lecture, I was still working in Sanoma, but life changes fast. And in fact, it's been just 2 weeks since I started my new role in the company called Starship Technologies. And based on the logo, perhaps you can identify the robots, delivery robots in Helsinki, Espoo at least, and in some other cities in Finland. So that is about at least one note on that. But the lecture today mainly built on the experience working in Sanoma, but obviously also a lot of information are pretty much general.
Sorry, Mikhail, I just changed by accident to host. You would need to share again your slides. Sorry.
Yeah, sure. Let me do that. Can you see it?
Perfect.
Great. Yeah, so maybe very quickly, again, what is a Sanoma? So as I put already on the slide, so for me, Sanoma is a very nice office building in the city center. So most likely you identify this building if you've been in city center. But on a more serious note, again, Sanoma is the largest media company in Finland, and it's also a private company. So while name Sanoma might not be immediately familiar, even to many Finns, you will likely recognize some of the logos shown on this slide. So these represent Sanoma's wide range of products, like major newspapers like Helsingin Sanomat and Ilta-Sanomat. So the TV channel Nelonen and some other very popular radio stations, and even beyond that. So I think it's truly fascinating when you consider the scale and the reach of the company, because according to the information provided by, again, some people in Sanoma, so they reach about 90% of Finns every day, meaning that people actually reading, watching, or listening the products of Sanoma. And altogether, I think based on my last information, there were more than 2,000 people in the company. So you can imagine that it's pretty much. It's pretty big, actually. So what kind of data Sanoma has? Because again, obviously today we're going to talk about data and everything surrounded it. In Sanoma, there are several types of data being handled on a daily basis. Customer data, again, is self-explanatory, I guess. So customer communication, meaning that how Sanoma communicates through which communication channels, like email addresses, phone numbers, and so on. Subscriptions, again, self-explanatory, but I can clarify a bit. So what kind of subscriptions Sanoma has, and on which products people are subscribed. Obviously, invoices, campaigns, meaning that, again, Sanoma sometimes send some ads, like if you will subscribe today to, for example, I don't know, theater, like a magazine, then you will get 30% sales. News article consumption, this is quite important. I would say funnel of the data, meaning that when people go to by using the app of Helsingin Sanomat, Ilta-Sanomat, or they go to the web page, obviously statistics are collected, like how many clicks, how many time people spend on this article, and then this information is forwarded to the so-called end customer. It can be editors, it can be the author of the articles, or it can be anybody else for whom it is relevant. Another maybe direction of the data, or let's say just other group of the data, it's related to the ads, because obviously Sanoma also sell the ads. It's from the newspaper, it's from the apps, it's on the TV channel, and it can be also different kind of ads, like for example, again, so the clarification is different depending on the what kind of source or where this app is actually shown. And also related to the ads, business customers. So it's more about, again, place to advertise some external products in Sanoma product. So maybe very shortly, again, I will walk through the plan for today's lecture, but as I mentioned earlier, my personal goal is to bring as much real-world experience as possible. It obviously isn't always easy, because real-life situations are barely, like, black and white, like in theory. and they often require a lot of domain knowledge and maybe context understanding. So you will maybe notice that through the slides. But one important note that definitely I will not focus on kind of deep database theory today, but instead I will try to show again some real examples how databases are used. Yes, and maybe one more note before we will start that I will do my best, of course, to explain the data Sanoma work with, but for obvious reason, I can't really share the real data sets or real data due to obviously privacy and confidentiality. So examples may be abstract or simplified, but they're all based on some real data, and the structure and the approach is obviously basically the same. So yeah, regarding the plan, maybe very quickly, there will be four main parts. So first, it will be introduction to a data platform. The second part will be will focus on the data onboarding process from the beginning, so from data producers or source databases to what is commonly referred as a data lake. In the part 3, we will continue this sort of journey by explaining how data flows from data lake into the data warehouse. And the last part wraps up with a practical end-to-end example of the data onboarding process in action and what is actually the role of the specialists who work in the data platform there. Right. And yeah, so I think we can start with the sort of maybe basic slide. You know, the typical problem in presentation talks, like the simple concepts that the audience already knows are explained, and some more complex ideas are skipped, assuming that they're obvious. So it's of course not because the speaker assumes the audience knows nothing, but because expected level knowledge isn't always clear. So if some of the concepts are familiar to you, so don't take it personally. Hopefully, you will still learn something new in that. So I want to begin maybe by explaining the terms data platform, data engineering. So I haven't found the better formulation of data engineering rather than took a print screen from Wikipedia. So data engineering refers to the building of systems to enable the collection and usage of the data. And this data is usually used to enable subsequent analysis in data science, which often involves machine learning nowadays, and also AI, of course. Yeah, and what is a data platform and what is the relation to that? So data platform is a technical team responsible for developing and maintaining production data, onboarding pipelines and operations. Generally, I would say that the team is responsible for onboarding production critical data and enabling stakeholders. You can, well, consider stakeholders like end customers, even internal ones, to consume the data to support business processes. The data platform is mainly, I would say, about technology, meaning that each platform uses a specific set of tools chosen for particular reasons. Typically, based on my experience, large organizations have more complex setups, and their tool set can be broader as well. On the slide, you can see the example of the services and tools that can make up a data platform. We'll discuss most of them in detail later, but to summarize, I would like to maybe focus on dividing them into two parts, infrastructure and data. So in case of infrastructure, we talk about usually cloud vendor. So on this slide, you see AWS. I do believe that you're aware about different cloud vendors. So the main, of course, the players are, or alternatives are Azure and GCP, Google Cloud Platform. And the choice is most likely can be just the choice between, Coca-Cola and Pepsi, I guess. So each company just decides what they like more. And obviously, sometimes there could be some other reasons, but in most of the cases, it's a matter of the agreement with the cloud vendor, also the pricing and how comfortable the company in generally or the experts using different cloud vendors. We need a place to store the code and keep it versioned, right? So, and in that case, it could be GitHub, it could be GitLab again. Again, we will go into more details later, but in short, we need something to automate the process of deploying our code. And in that case, we're talking about CI/CD tool. So on this slide, you can see the icon of GitHub Actions. Finally, in the infrastructure side, I would say data orchestrator, data orchestration. It could be also on the right side, but why it is on the left? Because it's basically a tool which involves automation of the data pipelines, and I still consider it as an infrastructure. So on the data side, we usually talk about modern data platforms, or cloud data platforms, or whatever they're called nowadays. Different names. It's a bit difficult to keep track on it. So we usually talk about Snowflake, Databricks. It can be also BigQuery. A bit different actually story, but still. So let's just say Snowflake and Databricks. Then we talk about so-called ETL or ELT tool. We'll discuss it later, but it's basically the tool that helps to model the data. It can be Matidon, can be DBT, and of course, there are some more alternatives. And finally, we talk about data quality tool. So data quality, it's maybe one of my personally favorite topic. Data quality is crucial. So we need to ensure that the quality of the data delivered to data platform is good, so that we can avoid making wrong decisions in a data-driven organizations. For example, now AI, uses more data than ever, and the poor quality data can be even more harmful, as you can imagine. So we have talked about tool. What about the setup of data processes? Of course, this is just one example, and different companies may adopt different strategies. So here it starts with what's called data lake. Data lake is, I would say, it's more a concept, not specific to our technology. It can be implemented in different ways. But in general, it refers to a centralized repository that allows you to store all types of data. It can be structured, semi-structured, unstructured, and without needing to adhere to a specific schema or structure the time of storage. Perhaps you can think about data lake as a collection of raw data, such as logs in different formats, again, without any schema, and it can be completely different formats. So in AWS, this is typically S3 bucket. Next, we have a data warehouse where the data is stored in databases and organized in a structured way. Data warehouse is a centralized repository designed to store structured, processed, and organized data from various sources. And unlike data lake, which stores raw, unprocessed data, data warehouse focuses on cleaned and transferred data that is optimized for querying and reporting. Data in warehouse is usually organized into tables and schemas, and it basically makes it easy to run analytical queries and generate business intelligence insights. So in short, again, a data lake stores raw and unprocessed data in various formats. Data warehouse is more structured, and it's focused on the data that has been already optimized for further analysis. And typically, the responsibility of data platform stops here, which looks, of course, maybe a bit simple by looking at this slide. But obviously, later on, the data can be used for applications, and it is used for applications. Typically, obviously, it's always reporting, dashboarding, machine learning. Almost each company now has machine learning team or specialists, data science, and some obviously more. So if we think about high level, I would say that most infrastructure of data platform is typically cloud-based. So, and it uses so-called platform as a service tools, low code or no code solutions. And the reasons for this, well, first of all, the company doesn't have so much infrastructure to maintain. Reduce dependency on experts. So this might sound a bit unclear, I would say, but what I mean is that, of course, if you don't have too much custom code, it's easier that everybody in the team can develop the functionality further, so it doesn't require like very deep understanding. And in that aspect, the trend, what at least personally I see nowadays in this area, is that people remain essential in a way that they understand the business needs. So you can imagine that we are not experts, of course, technical experts, but compared with AI or any other, automatic tooling, we understand what is required for end user, and obviously in that sense, the role I think is grown in the data platform. I would say that in generally, cost plays significant role of obviously, so the company can choose to keep larger team with more custom solutions and open source infrastructure and be dependent on the team, but in that case, you have more flexibility. In that case, you have more flexibility and the quality of your solutions will depend on the skills of the team. And the cost source here is, of course, the people, the compensation salaries, what you pay to the people, or alternatively, what I, again, provided on this slide, is to rely on ready-made services and tools where you don't basically need a big team, but instead you pay for the service and tools provided. So the choices, of course, depend on the company, what they want in the end. So to conclude this part, I would like to add that the data platform, I think, is a pretty unique team because it's responsible for delivering new data, but it's also expected that all the current process runs smoothly without any issues. This is sometimes a communication issue with other teams because obviously, sometimes other teams believe that if you build the process, it should work magically without any issues, but in reality, the reasons there could be a lot of reasons why the data process basically failed and it contained critical data and you have to fix it very quickly. And obviously, there's a lot of challenges along the way. I would say enterprise maybe a special case, definitely startup is a different case, but we focus today on enterprise. So internally, I would say that the process might be not as fast as wanted. Again, because of complexity of the company. So ownership in a way is also might be problematic because sometimes you want to identify the person who actually responsible for the product, and you cannot do it because it's just very unclear. Obviously, when you work in the data platform, you daily get a lot of ad hoc requests. So when you want to focus on something, it can be very interrupting when somebody asks you, can you do this very quickly? And sometimes very quickly might be not actually 5 minutes job. So communication somehow might be covered in this first point, which also might be a bit complicated. So what else maybe I would highlight from the slide is that I guess monitoring comes to observability, something what we will shortly cover today, but not in detail because it's a huge topic, of course. So like when you have a lot of processes, you have to somehow very effectively monitor and observe it, right? And it's not a very trivial thing to do. Yeah, right. So maybe to end up again this part and make sure that everyone is clear on what data engineers do. So let's consider right now a very high level example. Imagine that marketing team runs some campaigns across Facebook and Google, as an example, and they have no idea which ads drive the most clicks. So this process could start with the stakeholder needs making a request, right? So show monthly clicks per campaign. And as a data professional, data engineers might dig deeper and first ask which metrics matter. Is it click-through rates or something else? So how fresh the data should be, like every real time, or it is enough to update it every 3 hours? What is the data volume? And so on. After that, engineer basically work on the backbone. It's a data pipeline. So they extract the clicks by sometimes maybe unstructured data, load them into data warehouse. They clean the data, aggregate clicks into campaign level metrics. So basically transform chaotic data into clean tables so that the dashboard can query. And as a result, the dashboard after refreshes every 3 hours, giving marketers near real-time insights. And basically, that's how it looks on a very high-level picture. So now I guess we can move forward and do more practical discussion. So I guess all the lectures should have some kind of, smart citations. That's something what I found. Not even sure if it's the real author, but anyway. I think that this citation suits the whole lecture on data engineering in general. So to read it out loud, good data engineering is invisible, but without it, nothing works. And I hope that after the lecture, maybe you will get the same feelings. We can start, I guess, with some still maybe some more theoretical information, but it's actually very relevant for real work. So when we talk about data ingestion, we need to understand the different modes of it, right? So started from basics, of course, data ingestion, the process of onboarding data from source to destination, and the destination can vary. It could be data lake, as we discussed, it can be database, it can be data warehouse, doesn't matter. So the first type of it is batch processing, where changes in the source database, such as new records, are not immediately updated in the destination, but instead they are updated in batches. So it's a collection of many updates according to a set schedule. It can be once per day, it can be 3 hours, whatever you want. The second type is real-time processing, which is the opposite. So changes are immediately reflected in the destination database. Other factors to consider when you make a choice between which one should you apply for is, of course, latency, cost efficiency, and complexity. So overall, the choice between batch and real-time ingestion depends on the use cases. Real-time ingestion is typically used for monitoring and real-time dashboarding, while batch processing is more common for analytics. And obviously, important thing to remember is that the decision on which ingestion type to use should be based on business needs and also the maturity of data providers, because sometimes they can just tell you, we cannot really create a line on the real-time ingestion, and then you don't have a choice. So furthermore, we talk about load types. And in that case, we talk about full load, delta load, and change data capture. This slide focuses on full load and delta load, as you can see. So let's discuss each of them separately. So full load refers to ingesting all the data from the source system into the destination each time the process runs, without considering if any previous data already in the destination. So in simple words, it means that every time the ingestion job is triggered, all records from the source are extracted and loaded to the destination and overrides any previous data in the destination. This approach is the simplest, but can be inefficient if the data size is large, as it involves moving entire data set each time, even even if only a small part of the data has changed. So it can be used when the data volume is small, or when it is important to ensure that the destination system contains complete up-to-date snapshot of the data source. But otherwise, it's not very effective. And what is alternative? Alternative is to use delta load. As you can see, the destination table is exactly the same. But the data load, on the other hand, focuses only on the data that has changed since the last ingestion. So instead of moving all the data, delta load captures just the records that have been added, modified, or deleted. This is typically done by tracking timestamps, as you can see on this slide, or any flags indicating which records are new or have been updated. Delta load is more efficient than a full load in that aspect because it reduces the volume of data transferred, and it's particularly useful when the source system is large and only a small percentage of the data changes regularly. So this method helps save on processing time and storage, as only incremental changes are adjusted. So in both full load and delta load, the frequency of data ingestion can be adjusted based on business needs, of course. So for example, again, full load might run once a day, but delta load could run more frequently, even like 1 hour. Each 1 hour can be each 5 minutes. Again, it depends, right? Yeah, and then we talk about so-called change data structure. So let's now maybe consider a different case. Imagine record is removed from the data source, from source database. This is obviously delete operation, or perhaps it is an update. So these changes typically happen in real time. And again, it refers to so-called change data capture. Often it's called CDC. CDC is a technique to use to capture and track changes. So insertions, updates, and deletions in the source database in real time, in other words. It's similar in a way to delta load, but it's more granular and often implemented by capturing changes in the database level, such as using database triggers or transaction logs. CDC ensures that the destination always has an up-to-date copy of the source data with the minimal latency. So that is maybe the big difference with delta load. And for that reason, again, it makes it suitable for real-time data processing scenarios. Yeah. Actually, I like these formulations, which I got from the help of AI. So CDC is essential delta load on steroids, more granular and event-based. So I wouldn't make it by myself. In any case, just to summarize again, so full load, all data is ingested every time. Delta load only changed or new data is ingested, and CDC tracks and ingests changes at a more granular level in a real time. And to highlight it again, one important thing to remember that we decide on the ingestion type based on the business needs and maturity of data providers. So how this process looks in reality, the process of onboarding data from source database to data lake. Here's an example for the batch ingestion. So first, data arrives in, again, we assume that we talk about AWS environment, is so-called S3 bucket, so it's storage place. One thing to remember that in enterprise, and not only in enterprise, of course, I think from all companies, I hope, security is one of the most important things. And in that case, usually the data arrives as encrypted. And it's also archived. So obviously, encryption ensures that even if someone intercepts the data during transmission, they won't be able to read it. In that case, again, we're talking about encryption transit, meaning that the data is encrypted as it moves from the source to the destination. And why archived? Well, sending the data as an archive is just easier. So it's quite obvious reason, and reduces overhead of handling multiple individual files also during the transfer process. After the data in S3 bucket, there could be custom code, right? Running as so-called in AWS, it's called a lambda function, which is serverless compute basically. And the code just decrypt and archive your data. And after that, before data goes to data lake, the data should be standardized a bit. What does it mean in reality? It means that timestamp is added to the record when the data arrived, and the data is partitioned. So what does it mean in reality? It means that the data is organized in the bucket under a specific format. Can be, for example, year, month, day. This structure is important for backfilling the data when needed and make it easier to manage generally the data ingestion process. So the final data is a destination, the data lake, and a reasonable question to ask: how do we run all these steps together, and how do we run the same pipeline multiple times, like 100 times? And where's my mouse? The answer is again data orchestration or data orchestration tool, as we shortly discussed already. So in generally, orchestration ensures that each step in the process runs in the correct order. It can be custom-built orchestrator, can be ready-made solution. There's quite well-known players on the market like Airflow, for example, or Duxter, Orchestra, and many others. And with an orchestrator, you typically define a sequence of steps using Python or any other language. Well, it depends on the tool, of course, which you can choose. It can be even Scala if you want, if somebody still uses it. So orchestrator handles the logic of how the steps run together. And for example, when one step finishes, like the data is decrypted, it triggers the next step, like unarchiving the package and so on. And here partitioning plays a crucial role. So if you heard about big data, most likely you heard about partitioning because it's super important there. So you want to run the pipeline for new data. So data for today, for example, not process all the data in the entire bucket, right? And this is where partitioning by date becomes essential. So it allows you to focus on the latest data without impacting the performance of the pipeline or reprocessing the old data. Another way of or alternative to batch ingestion is real-time, of course. So here, again, different possibility how you can do it. Again, it can be streaming, which is out of the scope of this lecture. It can be so-called micro batches. So, which in my opinion is still real-time ingestion. And here's the one example of the tool provided by AWS, which is basically a platform as a service tool. So you don't need to manage any infrastructure. You basically just start using the tool from the beginning with some minimum configurations. I don't think that we have to really focus on that today, but it's just for your information that you don't need to quite often to build something from scratch. You can just use ready-made service or tool for that. But if you have any interests, I recommend you to read more about that. It's pretty fascinating tool in my opinion. So far we have discussed already a lot. So two types of ingestion mechanisms commonly used for data onboarding. Again, batch ingestion, real-time ingestion. However, when we consider real-world scenario, one important component is still missing, and this is CI/CD. So continuous integration, continuous deployment. Again, not sure. I'm pretty sure that you already used, for example, GitHub or GitLab, but I have no vision if it's the same for CI/CD. So I will cover it very on the very high level, maybe. So CI/CD is one of the most significant part in real life scenarios. Because it allows you to automate the process of building, testing, and deploying your code to ensure that updates are smoothly integrated and that your system are always up to date without manual intervention. So in simple terms, imagine you're working on modification in the code of a component, and the CI/CD allows you to keep your deployment under control by automating tasks like, again, running tests to make sure that your pull requests won't break anything, deploying code automatically to different environments like sandbox and production, ensuring that deployment process is fully automated. Well, that's the ideal picture, of course. There are two, I think, well-known players on the market, Jenkins and GitHub Actions. And of course, you can just read more about that if you haven't. So about the difference, again, it's out of the scope for today. Yeah, maybe now I think we can move forward. So monitoring and observability. Imagine that you have 100 pipelines, data pipelines, right? The critical question is how to make sure that everything works as intended. So you start your day, your working day, in the morning, and how to very quickly check it. So obviously, one approach is to set up notifications. It can be Slack notifications, it can be email notifications, and this way you can stay informed if anything goes wrong, and your team can react promptly, hopefully. Again, you can set notifications or alerts for failures, performance issues, or if jobs takes longer than expected. Another option is monitoring dashboards. So these dashboards provide real-time visibility into the health and performance of your pipelines or your processes in general. They can show metrics such as the job success rates, data processing time, and system resource usage, helping you identify potential issues quickly. There are different, of course, possibilities and tools also for monitoring observabilities. One known tool is Datadog, for example. But in reality, different companies adopt different strategy and different ways of monitoring. So, and finally, I would say when we talk about data, because it's data talk still today, one critical aspect which I wouldn't even consider optional because it is a must is again data quality. So data pipelines often process and transfer large volumes of data. And again, if the data quality is poor, it can lead to incorrect insights, broken reports, and the wrong business decisions even. So ensuring data quality involves implementing checks, validation, and within your pipelines to make sure that the data meets the required standards. So what should you choose? There's no right and wrong answers again, and the best approach, I think, just basically to combine all of these methods. And that would be maybe the best approach in my opinion. So perhaps you already gotten the impression that when we think about data ingestion, it often involves considering the overall system design, the architecture of entire component or tech stack. When you are building something from scratch, there is a list of key points that you must take into account during the design stage. So security, again, something what we discussed. And again, when we talk about security, it's usually it's encryption in transit, encryption in rest. So we cover both. Scalability, meaning that your components should be designed to continue working efficiently even if the data volume increases. And nowadays, it's pretty easy to do with the cloud, but then we go to the cost. So cloud services can become expensive very quickly. So it is essential to keep costs under control, and following best practices for cost optimization can help prevent a lot of problems. It's like, you have to think about choosing even the right storage options, or do you want to use serverless, or you want to build your own? So many options there. Design flexibility. So you have to think beforehand about edge cases, like what potentially can go wrong and how to, could it be recovered automatically, so-called resiliency, right? And as I mentioned again, monitoring and observability. So I would say by keeping this consideration in mind, you ensure that your data ingestion processes are robust, scalable, and well equipped to handle growth and unexpected situations in general. So this is, I think, in each part, if I remember, I have this section, so-called lessons learned. It's more about kind of my personal perception through the years in my career. So the first thing, what I would say, it's custom components are not easy to maintain and debug without understanding of the code. Obviously, if you like to code, you want to create more like custom logic because it seems more flexible. But for the companies, it might be a bottleneck because the person who creates, the person also can leave, and then nobody can actually maintain and even use it, which is a big problem. One important lesson is that less complex architecture is a better architecture. So don't try, we shouldn't really try to, to create a lot of layers when there is no need for that. So solutions should be flexible, acknowledge edge use cases. Again, one of my favorite, documentation is a must. So quite often developers just ignore it because we focus on business needs, business goals, but in reality, it creates more issues in the future, again, when nobody actually can, you continue using this component or maintain it or something else when the person who created the component just not available. Data contracts, it's a sort of the term where you discuss with the data provider about the details of the data, like when objects are expected, how many files and schema. This is pretty new, I think, term, even in the data field, and it's a bit difficult to adapt. But in general, it looks like a great idea if you don't want to, to put fingers into each other, like whose mistake it is that the data pipeline is broken. And some maybe final note is that it's always better to adapt the same approach of doing things between even different teams, because there always could be some reorganization, and different teams will become one, and then you will have completely different approaches of doing the same stuff, which is not great. Okay, so data in the data lake, and now maybe it's one of the most interesting parts. So we need to bring the data from data lake to the data warehouse. So here again, I would like to take still a bit closer look at some sort of theory, I would say, and understand the difference between transactional analytical databases. So according to my understanding, your lecture is mainly based on the transactional databases. And this talk is more about actually analytical, even though they're both relational, so it doesn't matter in that aspect. So this comparison is built around two terms, OLTP and OLAP, so-called. So online transactional processing and online analytical processing. And again, when we talk about OLTP, it's usually we talk about systems. So we refer to transactional databases, and we talk about OLAP. So respectively, we talk about analytical databases. So what sets them apart? OLTP databases are used in systems like, banking, e-commerce, where you process many fast transactions. Like when you go to the shop, to the market, like Prisma S Market, K Market, and you pay for your for your groceries. It's a transaction. It should happen very quickly. OLAP databases are actually used for analytics, reporting and data science. And so it's everywhere where you need to extract insights from your data. OLTP handles structured and relational data with the fixed and normalized schema, and OLAP actually have some flexibility. So it often uses even a flexible and denormalized schema. OLTP stores data in raw-based format, to quickly handle inserts and updates, and OLAP stores data in columns, which is more flexible and efficient for aggregation and large scans across data sets. So yeah, otherwise, also maybe important note about data processing. Again, OLTP is real time because transaction must be reflected immediately, and OLAP is more sort of batch or near real time. It's really depending on your use case. So on the right side of the slide, you can see OLTP system or databases like PostgreSQL. I'm pretty sure that you heard about it. MySQL, Oracle, MariaDB. They can be much more, of course. And on the left side, we have examples of OLAP platforms, which are designed for analytical use cases. So Amazon Redshift, Databricks, Snowflake, could be also BigQuery from Google. So these platforms are all use OLAP as a foundational concept, and they're rather purpose-built platform for data warehousing and large-scale analytics. So maybe to again repeat it again. So data warehouse is a data architecture system designed to store, integrate, and manage large volumes of structured data. And it is purpose-built to support OLAP style analytics and reporting. It's optimized for running complex queries, aggregations, and multidimensional analysis. And this allows organizations to derive insights from historical and integrated data. So many companies today use both OLTP for day-to-day operations and OLAP for in a data warehouse, again, to drive analytics and data-driven decisions. And these architectural separations is essential for both performance and scalability. So Snowflake, as I mentioned already 2 times, we are going to talk about this, is one of the most popular nowadays cloud-based data platforms together with Databricks. So initially, I think Snowflake was commonly referred as a cloud data warehouse. And for me, it's still cloud data warehouse, but it's based on my application. But the company, like Snowflake, prefers to call it data platform because, actually nowadays it goes beyond the traditional data warehousing even. And there's a lot of AI tooling. It allows you to build even applications in the platform. So it's definitely much more already. It was developed 13 years ago, and it is a SaaS, software as a service. So again, we have similarity with the clouds. You don't need to worry about infrastructure. It has separated cloud storage and compute, it offers on-demand scalable compute, so-called pay-as-you-go model. It's secure and easy to share, and it's already integrated. You don't need to do anything about that. And it's easily integrated with third-party tools. So this is very actually important for big organizations who collaborate a lot with externals, with external companies. So you don't need to think about, how you bring the data from external source to Snowflake. It's very easy to do there. That's basically how Snowflake UI looks like. And typically people do some development in UI. So unlike with OLTP databases, of course. This is quite technical slide, which I think that we can skip, but you have set of slides and you can maybe check it later if you want. Now maybe to more interesting stuff, at least in the scope of today's lecture. So when we talk about data warehouses, we often don't question their design. And nowadays, many companies adopt what is known as a medallion architecture, I think initially proposed by Databricks. And this architecture is designed to answer a key question: how do we organize all these data in a way that it is maintainable, trustworthy, and analytics ready? That's where the medallion architecture comes into play. It's a logical design pattern that can be used within Snowflake or Databricks or whatever you're using as an OLAP-based system to structure the flow of the data from raw ingestion to curated business data sets. As you can see, we start with the so-called bronze layer that represents raw, unprocessed data. Again, think about that like completely, some kind of logs in very unstructured format. This is foundational data, on the other hand, often ingested from various sources, and that needs cleaning and transformation. Silver layer is where the data undergoes some transformation, cleaning, and enrichment. And this layer is where the data starts becoming more usable for analysis, but still may need additional refinement for specific purposes. And finally, the gold layer is the final, most refined version of the data. Again, the data here is already aggregated and optimized for business intelligence. We talk about reporting, dashboarding. So this is the data when the business terms rely on for making decisions. And obviously, different people within an organization typically use, develop, and maintain these different data layers, reflecting the progression from bronze to more refined business aggregated data sets like silver and gold. And this is just a very quick example to show you how it can look like in reality. With Medallion architecture, we organize our data pipelines into bronze, silver, and gold layers, which is great for operation data flows. But how do we design the overall structure for enterprise data? How do we ensure it's scalable and maintainable, and that it is aligned with business processes? Because this is, after all, the final goal. So this is where data modeling frameworks come into play. They provide strategic blueprints for building and evolving data warehouse. And there are several data modeling approaches, such as Inmon, Kimball, Data Vault, and even more. But however, the reality is more complex. Yeah, there are some companies who can tell you that, we use Data Vault, and that's great. But quite often when we talk about data for analytical purposes, data modeling becomes essential. And while there are different ways, again, to model data in data warehouse, it's quite rare that one single model can be fully applied. So in practice, what is used is, I think, hybrid approach. Again, because big organizations often have very complex logics and processing, and each domain may follow its own unique approach to data modeling. And finally, business needs take priority. So it often leads, again, to a mix of different techniques, because you have to deliver the requirements across different departments, systems, domains, and use cases. So let's go through the example of data modeling in silver layer. That's where actually data become already clean. And where we start structuring and enrich the data from raw form into so-called core analytical assets. At the top, you can see the invoice table. This holds high-level invoice information, like total amount, date, customer ID, and it's identified by invoice number as the primary key. Then we have the invoice row table. There are line items for each invoice. It has a composite primary key made of invoice row and invoice number, invoice NO, and a foreign key pointing back to the invoice, right? The customer information is referenced but not joined in this view. We assume it can be joined later based on the customer ID. And finally, at the bottom, we create what we call a core asset. It's denormalized, but enriched table that joins invoice headers with their corresponding line items. And this gives us a complete view of each transaction, and it stays in the silver layer. So these core assets are clean, traceable, and structured, and making them perfect building blocks for the gold layer, where we can apply business rules and aggregates and create metrics for reporting and dashboards. No, sorry. Yeah, this one. And once we have chosen a modeling approach and structured layer accordingly, the final piece is to expose it in the semantic model. So what it means in reality, it's a business-friendly layer that defines key metrics and hierarchies. So in this slide, again, we continue working in the silver layer, but now we shift from physical joins and courses to semantic modeling perspective. This is what we call semantic core. It represents structured and connected view of key business entities: customer, product, subscription, and invoice. So each table has clear primary keys and foreign key relationships. Subscription sits at the center, linking customers to product, and invoice tracks transactions based on the subscriptions. So while this model still lives in the zero layer, it's not raw anymore. It's clean, conformed, and enriched enough to be reused across multiple use cases. And it is called semantic model because we start aligning the technical data with business meaning. This structure forms the foundation for reusable metrics and gold layer data products. And these names, the names of the columns, the name of the tables, are understandable by business stakeholders, which is the key also here. So now we can finally move to the gold layer, where data is shaped and optimized for business consumption. This is where we build so-called data marts, structured around key business processes. What you see here is the classic dimension model built from semantic silver layer, which we discussed. At the center, we have our fact table, F invoice. This contains measurable business events. In this case, line level invoice data, including quantity, unit price, and line total. It is connected to it is a dimensional table. So it's the customer, the product, and this enrich the fact with the descriptive concept: customer names, regions, product names, etc. And it also shows the relationship. So F invoice links back to the invoice in the silver layer, and it uses foreign key, the customer, the product, for filtering, grouping, and aggregating. And finally, the structure makes it easy to answer business questions like, how much did each customer spend last month? Which products are generating the most revenue? So the gold layer is also a perfect launching point for dashboarding, self-service analytics, and yeah, so business critical aspects. In short, I think now we've gone through raw data in bronze to structured validated data in silver, and now to insight-ready data marts in gold. Yeah, so technical question, where can these data and semantic models be built? And here we started to talk about so-called ETL and DLT tools, which stands for extract, transform, load, or extract, load, transform. So what is the distinction between them? Traditionally, ETLs involved extracting data from source system, transforming into usable format, and then loading it to a data warehouse. However, with modern data architectures, the process can be shifted to, it was shifted towards ETL. No, sorry, ELT. So yeah, where raw data is loaded into the data warehouse first and then transformed in the warehouse itself. So this is where some confusion may arise, because Matillion is officially called ETL tool, but it's typically used as ELT. So perhaps it's too much information for you, but it's just again to show also something that even as the tool can position themselves, the application can be different in reality. And it happens a lot in the data field nowadays. So yeah, in generally, again, to summarize it, ELT or ETL tool, this is the tool which helps us to model the data. So that's very short explanation of that. So here is a print screen from Matillion, how it looks like in reality. So how I call it, like ClickOps. So you create the boxes with the different operations. So a series of boxes connect to each other, and which we can refer to, well, again, as ClickOps. And these boxes represent individual tasks on transformations, where you define your data model. So you do some joins and whatever you want to do there. DBT is a bit different. It's a code-based tool. So, but it's out of the scope for today again. So let's now build the full picture. So again, from now, I guess we can focus more on practical examples. So how the process look like, how the entire process look like in reality. So step one is a data ingestion again into the data lake, as you remember, or well, the first step of the data platform. So it's a data. So process happens through batch ingestion in that example, meaning that it is done on daily, weekly basis. So the data is encrypted and archived in S3 bucket, and once the data in the bucket, orchestration pipeline is triggered, and the pipeline will decrypt and archive this data, partition, and load it into the data lake. So that was the step number one. Step number two, the data is ingested from data lake to data warehouse for analytical purposes. So in that case, we're talking about that data is onboarded to Snowflake. And in the Medallion architecture, the first data layer is a bronze, which is essentially raw and unprocessed data. So in practice, it looks so that the raw data is ingested into specific schema. In that particular example, it's called landing, though the name can vary depending on your implementation or the practice in the company. And after the raw data in the landing, it moves to so-called replica schema. So again, you might wonder why it is moved to another schema, even though it is still considered raw and bronze. So this is technical implementation choice. As we discussed earlier, different ingestion modes are possible. And in this case, if we talk about delta load, the replica schema acts as a historical table. So it contains all the data all of the time, while the landing schema only holds the records that have changed recently, since the last update. After that, ETL, ELT tool is used to enforce primary keys, remove duplicates, and set up rules for delta loading. And once the information process is complete, the data moves to silver layer, typically stored, well, it's definitely stored in another schema, again in Snowflake. So step number three would be the step where the data is modeled using, for example, Matillion tool, where core assets are created in data marts form. And this process results in the creation of gold data, which again, highly refined, business-ready data that can be used for reporting and advanced analytics. This slide, I think we can skip. It's a bit technicalities related to Snowflake. Again, you can take a look later if you're curious about it. And very quickly, again, when we talked about monitoring observability, we briefly touched on data quality, and here's practical example how it looks like in reality. So for each table in the data pipeline, you can create data quality test to ensure that every table is fully covered in the data lineage. And in that, and then you can also set up notifications like Slack. You can build even Grafana dashboard to make sure that everything is covered and you are pretty sure that everything is fine with your data pipeline. So just an example. So what should be considered when working with the data onboarding to data warehouse is highlighted on the slide. The main configuration outlined, and these are typically handled by Snowflake, which is of course good. Or it can be also handled by any other modern data platform. So cost optimization, I think, still remains a key focus. Similar to the cloud, it's crucial to continuously monitor and adjust your data storage and compute usage to ensure that costs are kept under control. Monitoring and observability usually requires some work. So it's not always so that the data platform provides you some ready-made solutions, so you need to implement it by yourself or using some external tools for that. And I mentioned earlier the term like data contracts, I think still very important. And, it would, of course, always great to have it in place. And now I guess, yeah, so we still have lesson learned section. It's more about like what can be done maybe differently based on the experience. So I guess it's self-explanatory in a way. So I would maybe just to focus on, again, something that it's very important to find the balance between moving too fast and too slow, especially if you do some implementation from scratch. So if you do something very fast, most likely you will net up in refactoring things all of the time. But moving slow is also not the best because obviously we don't want to stick at some problem for a while. Also, maybe regarding the speed as well. Nowadays, the tools and platform provides a lot of functionality, and it is important to learn about it because otherwise, we can end up in the case when we work on some custom solutions when the tool already provides it or service already provided. Maybe as you already learned, so some popular terms like middle architecture is great. It looks simple, but in reality, it looks a bit more complicated. And it's always important to understand or design what does it mean in your particular case for your data warehouse, in your team, and how it can be also be understandable by other teams. And obviously, sharing the knowledge, well, I guess not new for you, with your colleagues, it always helps. It's a great practice in generally. So yeah, I'm sorry, I think we're a bit over time, but perhaps this section will not take too much time, and I personally hope that it may be the most even interesting. So this part is not trivial, I would say, and we will take the perspective of a member of data platform team and imagine what the process would look like if there was a need to onboard a new data sets, take into account all the information, what we learned so far. So let's walk through the end-to-end data onboarding process, starting from scratch. So it's similar to what we discussed in the beginning, but in more details. So we assume the data is not yet in data lake. We need to build all necessary processes to get it there. The part one is basically moving the data from the source to the data lake. And this phase involves close collaborations with data providers. And it could be broken down into these such parts as first establishing a data contract. So before diving into the technical details and implementation, we need to align with the data providers. We need to agree on data specifications, like what data we will receive, what format, structure, and schema. We need to agree on the frequency, volume, and some security measures. So think of this as a sort of settling the rule of engagement to ensure that there's no surprises down the line. After that, the data engineer takes over, and while the contract is established, the data engineer takes the lead by designing technical tech stack, or you can think about like a component which would process the data. In that case, the key task would include, building automated pipelines to again unzip, decrypt, standardize the raw data, and something like that. Obviously, again, we follow good practices, right? So, and the engineer works collaboratively, not in isolation. So code is pushed to repository, pull requests created for a team review, feedback is addressed, and this could include optimizing costs if your code is not so effective, or the service what you choose is not effective, improving edge cases, handling, simplifying the design, and it can be iterative process. So I guess no need to put it here. Obviously, the testing is an essential part of this process as well. And once the code is approved, the pull request is approved, the pipeline can be deployed to production environment. The job isn't finished yet. We must validate that everything works again as expected through the testing, as I mentioned right now. Yeah, and one that is in production, your code is in production, we assume that the data is delivered to the data lake. So after that, the next phase is transforming the data into structured and, you remember, queryable and actionable data sets within our data platform, Snowflake in that case. And this is where we introduced, quality check scalability to convert data into analytics-ready assets. So we begin with the standardized raw data sitting in the data lake. While the data is available, it's not yet structured for efficient analytics. So the objective is define the target schema, so how the data will be modeled and organized in Snowflake. The data engineer now set up the core Snowflake structure, like schema and design, schema and table design. It decides on the schedules for Snowflake. So when the data should be onboarded to Snowflake data warehouse, it can also decide on compute configuration depending on the technical implementation. And again, the same, all changes are submitted to as a pull request. So again, ensuring the alignment with the practices. And when it is ready, pull request is ready and approved, engineer can test the changes in some development database. We don't want to break a production database, right? And after that, again, engineer can deploy it to production database and together with the code. And finally, again, with the engineer can work on the data quality checks to making sure in the future that the data is according to the expectations. And then finally, how validated bronze data sits in Snowflake. It's time to take the next step. So raw data by itself, again, isn't useful. We need to transform it into clean data and analytics-ready data sets. This is where production ETL ELT jobs come into play. So we need to design ETL job, again, where we enforce primary keys, where the data is cleaned, columns are renamed and formatted. Remember semantic model. And in similar way, it goes to pull request. And finally, also data quality checks. Yes, right. So that's, I think, roughly was the process. Actually, let's skip this slide. But it's very similar to that. It's called part 3. That's where we defined data and semantic model. And in that case, the difference is that depending on the team, depending on the company, it can be maybe not data engineer, but analytics engineer. It can be ETL engineer. So another person who understands data maybe better than a data engineer. So it's less technical, but more data-related work. But the structure is exactly the same as you can see here. So it's also Snowflake, so data platform. It's also Matillion ETL tool, and it's also GitHub. So the structure is pretty much the same. So yeah, we're approaching the end. And I would like to focus on main, I would say, key high-level considerations. So while many of us in tech, I think, passionate about the tools and platforms we use, about technology, it is important to remember that technology is not the end goal, and in business at least. So it's simply the most effective way to support business outcomes. So after all, the business doesn't care whether you use AWS, Azure, Databricks, or Snowflake. What matters is the value delivered. Solution may seem simple, especially when the technical foundation is already in place. However, without truly listening to and understanding the end user, risk solving the wrong problem. So communication is a core, in my opinion, and clear communication, empathy, and general sharing understanding are far more impactful than the code alone. So good communication is not just about gathering requirements, it's also about explaining why factors like scalability, maintainability, and testing matter. Because while business stakeholders don't need to know the technical details, they must understand the implications. And it's our responsibility, after all, data platform responsibility to communicate technical trade-offs in a way that makes sense to them. Find the balance between moving fast and moving right. I would say that moving too slowly drains momentum, but moving too fast often leads to, again, fragile solutions that need constant refactoring. So finding sweet spot is challenging, but it should be final goal. And as soon as possible, solutions tend to stick. So just because something was built quickly doesn't mean it should stay that way forever. So business might move on, but we live with the code and we live with the component. If we don't guard against shortcuts becoming permanent, we are the ones who will pay for it in the long run. So I would like to, finalize my lecture with one more smart citation, that the biggest challenge is becoming data-driven, not technology, it's a culture. So something what I think many people learn with experience, even the technical people. And I really do hope that you will start your professional life with the same kind of approach and understanding. And again, I'm really sorry if that took a bit more time than I expected from the beginning. So, but I don't want to skip one of the most important slides. So, and thank my colleagues from Sanoma, who helped me to also review and help with some parts of the lectures. Also, some people who, so Enrico, who actually let me know about this lecture at all, and of course, Alex for inviting me, and obviously to all of you for your attention. And completely final slide is that, we can be friends in LinkedIn if you want. So I'm actually kind of active there. So I like to write some technical posts, and also I share a lot of my personal experience. So if you find this interesting, so just send me the request. But yes, I think it's finally all from my side, and definitely if you have any questions, I would be happy to answer.
Thanks a lot, Mikhail, for this exciting talk, getting some insights into the workday of data engineers on a very, how should I say, working on very large systems. So are there any questions or comments from the audience? Please post them in the chat. Okay, I'm not sure if my chat is somewhat limited or I also allow you now to unmute yourself. So if you want to ask a question, just speak up.
Yeah, thanks for the great talk. I got interested. Is it often just one same data engineer throughout the whole data onboarding process, or are people usually focused on like specific steps in refining the data from bronze to silver or similar?
Yeah, that's a very good question. I think that it depends. The answer again is it depends. So it depends what kind of approach company adopts. So I think in generally, if the company is not very large, it is one data engineer who does most of the things, including data modeling, But in large organizations, quite often when we talk about data modeling, especially part, so it's basically the middle of silver layer. It's already analytics or ETL engineer or somebody else with another title like data warehouse engineer who focus more on the data aspects, So they might not be very technical in the way that they cannot build the whole pipeline. They cannot maybe do something within the cloud, but they know about the data and they know about the tool, like the tool where you can build this model, like Matillion or DBT, and they know about Snowflake. So yeah, I would say that two different cases. But in general, I think that it's always good to have different people for this, because also my hope from this lecture was that data engineers should do a lot, have to do a lot. So and data modeling is again, as you perhaps know, is a separate big field. So being an expert on everything is also bring the danger that you might not be a good expert in everything. So if somebody would ask me personally, I would say that it's good to have separate people, separate experts for just data modeling purposes, if it is so relevant for the company. Because also, sometimes the data can be quite simple, and it just, you just build some fact tables and that's it. And in that case, perhaps you don't need separate experts. But in enterprise, I don't believe it is the case. And for that reason, I do believe that, again, analytics engineers, ETL engineers should be involved in the process at some point. So I would say roughly, again, data engineers would work from the scratch up to the middle of silver layer, and from middle of silver layer up to gold, it will be already, let's call them analytics engineers. But infrastructure side is always on the data engineers. So they're responsible for the whole process as such.
Thanks a lot. Any other questions? So, Mikhail, you are now working on this data collected by these delivery robots. Did I understand correctly?
I do, in just 1 week though. So
Okay. And do you know, or maybe you cannot tell, but will you have then access to the raw data that the sensors of these robots are collecting?
So what was your question? When I will have the access, or?
Yeah, will you work with raw sensor data from these distance sensors or collision sensors?
Yeah, yes. Yes, good question. Again, even in my team nowadays, like in my new team in Starship, we have different people. So we have data engineers and we have analytics engineers. So similarly, data engineers are more responsible for technical parts. So we bring the data. So imagine that the robust data goes to some general storage, and we bring the data to data warehouse, so that this data can be accessible by anybody. But if we talk about reusable data, it's typically already the task of our analytics engineers who work on the data models. So how you can make sense out of these sensors, right? So how it can be reused by other teams to improve the product and to improve the algorithms. So that would be already the task of analytics engineer. But obviously, it's also our work to understand what we're bringing to the data platform, what we're bringing to the data warehouse. So short answer, yes, I definitely will. But longer answer that I will work more kind of on the delivery stage, when other experts will work on the making sense out of this data.
Okay. Thanks a lot. Again, thanks a lot for this great talk, and it's good to see or give students an impression about the importance of data, which seems a bit like the boring part of applications or companies. And you hear about these cool LLMs and AI models, but the success of all these AI applications rests on the data infrastructure in the end. Without training data, good training data, reliable training data, there is no AI.
Absolutely. I completely agree with that. And yeah.
Okay, yeah, thanks again. And yeah, I hope you allow me to share the recording on the student on the My Courses page and your slides.
Yes, absolutely.
Yeah.
Yeah.
Okay, thanks a lot, Mikhail. Have a nice evening.
Yep. Thank you all. Have a nice
Bye-bye.
evening. Bye.
Bye.